Hello, how's it going? Long time no speak. As you can see behind, the Russian clock is going. I can't zoom in on it. It's going. It's actually made me realise that they are actually quite dim, and I think I might buy some new old stock tubes and make a video on replacing all the tubes. I don't know. But yeah, so this is just a little update about, well, you guessed it, Game Boy machine. I did a builder's live stream just a second ago, just to kind of show the test, and annoyingly it wasn't working that well. Like I finished today building these things, which are called CPU modulators. Basically they are, if you look back there, you could see there is an LTC1799 chip, and then there's a mixer that's sending in different voltages, so you can send in two different CVs into the CPU, as well as a coarse tune. The other thing is, all of these CVs are bused, and when you plug in a thing, all of them are connected until you plug in a jack, and then that makes that one isolated. There's going to be one for each column of Game Boys of these. I've got 4 at the minute. There's going to be 8 in the end, and these are used to vibrato, frequency modulate, and just detune the Game Boy oscillator that it's assigned to in that voice. So each of these will control 6 Game Boys, 1 in each voice, and there'll be 8 of them, so you can detune all the Game Boys in the voice to each other. So that is that. You haven't seen much of this at all, so I'll show you what's been going on. So this is test rig number 3. It's basically parts of the finished Game Boy that I've got so far, as well as just solutions to problems that I found. So basically, let's start by looking here. So this is just a test prototype Arduino boy. We'll talk about that in a bit. But what we got here, so this is the ridiculous amount of buses between and connections between Game Boys I need to make with other things. And this is only the connections going along. This isn't the connections going up. So this first bus line is for analog power supplies and analog stuff. This probably won't be that prevalent in the Game Boy cabinets, because the only ones that are going to need to be powered are the VCAs and the filters at the end of the Game Boy cabinet. So this won't be there in that Game Boy thing, but this will be on the cabinet that controls all of the modulation and stuff. Looking to the next one, this is the main one for the connection to the Game Boys. This includes the Game Boy's power, the Arduino Boy signals, which is the MIDI stuff, and also the stuff that keeps all the cartridges. If you can see, all the cartridges in sync. Each cartridge has a wire coming from them to make sure that they're all on the same program. It's pretty silly. There's another one here, and this one is to sync up all of the screens, so I can control all of the screens' backlights separately, so I can make them, you know, kind of make patterns in time to the music maybe by the end of it. Right now they're all completely on. I've literally just wired up this bus to make them all connect up, but they'll be doing separately. One setback was the audio was going to be in this bus line with all of the voltages, but the thing is, the signals coming out of the Game Boys are so low that you can hear all the digital signals going to everything else through the audio. So I've had to make a separate audio bus, if you see, like just a little free wire things, just so they're nice and separate and there's nothing going on there. And that's going into a mixer at the other end, and then that'll go into the filter and stuff. But they're all now running MGB. I don't know whether you can see that. MGB, and 4 of them are being controlled by certain CPU modulators. There's a couple of vibrato ones plugged in with vibrato. The rest of them are slightly demodulated. Every single oscillator, there's 6 Game Boys here, 2 oscillators running each, so that's 12 oscillators. Most of them are detuned to each other, and they're all in pretty much different octaves. And right now they're doing a drone. So I'll just press play on this, because I can't actually make the sound stop because they're made to be oscillators. So the stopping stuff is in the VCAs and stuff, so I'll just turn it up on the mixer and I'll show you what's going on. So yeah, all in all, it sounds quite large. That is only 6. Each voice will have 8. Only 4 of those were detuned at that point. So by the end of it, you'll be able to detune all 8 to make it even sound really big. Right now, it doesn't sound massive because I haven't been able to get them low enough, but that's down to fine-tuning the CPU modulators. And yeah, after that, then it's onto the filters and the VCAs, and then after that I will be starting to find time to just literally kind of sit down and keep on building the same thing over and over again until it's all finished. So yeah. Oh yeah, and also one more project that's gonna happen, I'll probably leave it till last, but I need to double check it will work, is the modules that are to play all the buttons at the same time. I'm going to make them so you can control all 50 Game Boys with one controller Game Boy, and then I'll load something like Tetris onto them. Apparently the randomness is all down to the internal clock, and since all of the internal clocks will be synced up, there will be no randomness. All the randomness on all the Game Boys will be the same, apparently. We'll see if that's the case. I don't know. So I think the only way to work it out is to actually find out if in theory that happens, and when you add certain CPU modulations to change that, will the randomness change? If you turn one off and turn it on out of sync with the other ones, will the randomness change? Who knows? But this is all questions that will be answered when the whole machine has been built. But let's see. Anyway, that is just a little bit of an update on this project. So yeah, bye.